All right, so I want to do the Unit 4 test, so we'll go for it. So number one says we got our system of equations here. It says draw the axes and graph the system. So we've got these two equations. Now I can look at this and I can look and see the y-intercept is going to be 3, and it's going to go up with a slope of 1. For this one, we have the y-intercept is 0, and I've got a negative slope. So I'm pretty good to draw the axes however I want. You may want to double check it first with Desmos and see where you want your axes. I think that since I'm going to go 3 and up and then down, actually, that looks like that's not going to be too good because I'm going to go from 3 up. This one's going to start at 0 and go down. So I expect them to connect around there. So maybe I actually want to go here and draw my axes like this. So I drew the axes. Now I have to graph the system. So again, like I said, for this one, we've got a y-intercept of 3. So 1, 2, 3. And then I've got a slope of 1. So I'm going to go up 1 over 1, up 1 over 1. And I can go backwards. So down 1, back 1. So that's this line. Then for the red one, we can see I've got no y-intercept. So I know I'm going to start right in the middle here. And I've got a slope of negative 1. So I'm going to go down 1 over 1, down 1 over 1. And again, I'm going to come back this way. And then when I draw my line, I can see pretty clearly where the solution is going to be. So the solution is going to be right there. That looks a lot like the solutions at negative 1.5. And then if I go up 1.5. Now, since I got decimals, maybe I'm a little bit unsure. That's okay. So we'll throw this into Desmos. We got x plus 3 and negative x. If I look there, they connect right there at negative 1.5, 1.5. It's a little bit easier to see. So again, might be helped to graph first just to see where the connection is. See where that intersection is? That intersection is where the one solution is. That's what we got for this one. So pretty nice. All right, for 2, determine whether we have no solutions, infinite solutions, or one solution. Now most people, again, are just going to graph this. So y equals 1/3 x. So we have y equals 1/3 x. I totally forgot the rest of the equation. That's okay. Plus 2, and then x plus 3y. Equals 6. I'm going to double check to make sure I type that in right. X plus 3y equals 6. 1/3 x plus 2. All right, and if I look at my graph, I can see right there, there is a connection. So since they meet, that means we're going to have one solution. So we'll go ahead, we'll pop that in. We've already got our answer. Our answer is going to be one solution. So not really too difficult. Again, we'll get our confirmation there. That'll be our justification, is that on this graph, you can see there is a connection. Those two things do connect. Now, if you want to do it by hand, that's fine. Not too crazy to do this one by hand because this y is already by itself. So what we would do is we would use like we did in section 2. Take this and plug it in for the y because the y is already by itself. So we get x plus 3 parentheses 1/3 x plus 2 equals 6. And we can see why, okay, that makes sense. Even though we have the 1/3, the 3 is going to kind of nicely cancel it out when we distribute. So x plus 3 times 1/3 x is another x. 3 times 2 is 6. Equals 6. We'll minus 6 both sides, so that 2x's is equal to 0. Combine those as like terms. Divide both sides by 2, and we get x equals 0. So x equals 0 is a solution. We know 0 is the right answer. It's not no solution, and we can see right here, we connect right at 0 when x is 0. So again, based on this, I could also just pick one solution. So remember, no solutions is if you get a number equals a different number, because that doesn't work because the number can never equal a different number. And infinitely many solutions is a number equals itself. So that's what we'd have for infinite solutions. Now again, if we wanted to figure out what this y coordinate is, I can plug 0 in for x right here and find out that y is 2, but we didn't need to find out the actual answer. All right, for 3, it says from the graph shown, what's an approximate solution to the system of equations? So again, we can see we're in this box. And we can see we're kind of down here. So maybe negative 0.8 for the x. And the y, maybe negative 0.9. It looks like it's a little bit closer to the line. Maybe not. As long as you're close, that's fine. You don't want to go past negative 1 because this dot is clearly not outside this box. So we want to make sure that we're inside the box. 0.5 would be a little bit iffy because that's kind of right there in the middle. And you can tell it's more than negative 0.5. So it's closer to negative 1 than it is to negative 0.5. So as we got for 3. For number 4, Raul bikes 6 miles home from school at a rate of 3 miles per hour. Leah leaves school 30 minutes after Raul bikes the same route at a rate of 4 miles per hour. How many hours does it take Leah to catch up with Raul? So we want to get each of them to have an equation. So for Raul, he's going to go 6 miles from home. He's at a rate at 3 miles per hour. So his distance is y equals 3x. So that's nice. For Leah, she's going to leave school 30 minutes later, bike the same route, but she's going to go at a rate of 4x. So what information have we used? So Leah leaves school, bikes at a rate of 4 miles per hour. Raul leaves school at a rate of 3 miles per hour. All right, so we got a couple other numbers in here. Now the 6 miles doesn't really matter. That's just kind of how long the distance is. We're not going to use that at all. But this 30 minutes does matter because we have to take that into account. So if Leah leaves school 30 minutes after Raul, that means Raul has a 30-minute head start. So we have to then be really careful with our variables here. So we want y to be the distance. And our distance is going to be in miles. But we need our x's to be the same. So x, we have to make a time, but we have 2 different times because Leah has a time that she leaves school and Raul has a time that he leaves school. So I'm going to make x the time that Leah leaves school. So time after Leah. Which means Leah's equation is okay because she leaves at 0, but Raul doesn't leave at 0. Raul has a bit of a head start. So for Raul, we have to change his equation. So instead of making this 3x, we need to make this y equals 3x plus a half hour because he gets an extra half hour. So why does this make sense? Well, if we plugged in 0 for x, so right when Leah's about to leave, Leah would have a value of 0 because then we get y equals 0. So Leah wouldn't have gone anywhere. But Raul would have biked for half hour. So 3 times 0.5 is 1.5. So these are actually the 2 equations that we want to do. So it says, how many hours does it take Leah to catch up with Raul? So if I'm going to solve this, again, I could either do it by hand or I can do it with the graphing calculator. If I want to do it by hand, it's nice because, again, this is already by itself with the y, so I can just plug this right in here for the y. 3 parentheses x plus a half equals 4x. We can distribute 3x plus 1.5 equals 4x. Minus 3x on both sides, and we get 1.5 equals x. Now again, I got to be careful. I want to double check. X is a time after Leah, and that's what we're looking for. How many hours? So that's our final answer. So we get 1.5 for x. Again, if we want, we can graph these two. 3 parentheses x. Oops. Y equals 3 parentheses x plus 0.5, and then y equals 4x. I kind of like the red and blue, so I'm going to switch them back. You can use whatever colors you want. And so it looks like we're going to have to zoom out a little bit, but over here we do get a value at 1.5. And it turns out they do meet at 6. So it turns out they meet right when Raul gets home. Because Raul's going to bike for 6 miles, so right when he gets home is right when they're at the same time. So there we go. All right, moving on. So for 5, what is the solution for the system of equations? Again, we got 2 options. If we want to do it, we could do it by hand. Again, since the y is by itself, since a letter is by itself, I'm going by hand. Substitution is going to probably be a little bit faster. negative 2x plus 3x plus 7 equals 22. Now, a lot of people had trouble here because this is a plus sign. The plus sign is a separator, so that means we're not multiplying the negative 2x. This is just like if there were 1y here. We're going to take this 1 and distribute this 1 to both pieces. We're not distributing this 2x. It's off by itself because it's with the plus sign. So if we do distribute that, we get negative 2x plus 3x plus 7 equals 22. And we can minus 7 both sides and combine like terms here. So x equals, we get 15. Okay, that's a pretty big number, but that's all right. Pretty quick to plug in for y, because we can take our x equals 15 and just plug it in here, because y is already by itself. So y equals 3 times 15 plus 7. Y equals 45 plus 7. Y equals 52. Again, I'm a little suspicious that those are some pretty big numbers, so I'm going to use my graph to double check. And it's totally fine to double check it. So we get y equals 3x plus 7. And for the one, negative 2x plus y is 22. Now again, we can see these two lines. When I go back home, it looks like there's no solution because it doesn't look like they touch. It looked like they've got the same slope, but again, one of them is just slightly different with the slope. So I'm going to zoom out a lot because I know I got to go out to 1552 if I'm right. And we got 1552. All right, I zoomed out. I'm pretty happy with my answer. I verified it, but I got one more step to do. So now that I'm happy that I got the right answer, I got to remember how I want to write my answer. So again, with the last one, here we just wanted x. So that was okay. Over here, remember I wrote my coordinate pair. Here, we didn't have to give an answer. Here, we did the coordinate pair, so we have to remember always at the end, we're going to write it with a coordinate pair if it wants a solution, not just one thing. So as a coordinate pair, it's this 15, 52. So I'll write that 15, 52. So again, we're all set. It's always x, y. All right, for 6, we got another one of these. Looks very similar. Y is already by itself again. This time we're going to take the bottom equation and plug it into the top. So we get 2x plus 5 parentheses negative 2/5 x plus 4 equals 20. Same deal. We're just going to distribute this 5. So again, remember the 2x is over with the plus sign. That doesn't get distributed. So 2x, so 5 times 2/5 is negative 2. 5 times 4 is 20, so equals 20. So just like before, we're going to minus 20 and combine like terms. So this side, 20 minus 20 is 0, but 2x minus 2x is also 0. Since 0 does equal 0, this is one where we have infinite solutions. So remember, if we were to have something different, if we were to have something that was, say, 3 equals 0, this one would be the no solutions. So that's the difference between the infinite solutions and the no solutions. Infinite is number equals itself. In this case, 0 is the same as 0. No solution is two different numbers. All right. For 7, we got a real-world problem here. Luke sells cakes for $30 each. He's got his expenses, $12.25 per cake, plus $1.25 for a mixer. How many cakes must he sell for his revenue to equal his expenses? So again, we want to remember revenue is the amount of money that you make. So if we look at how much Luke makes, he's going to sell his cakes for $30 each. So our revenue equation, y is equal to 30x. Again, down here, I'm going to write down what my variables are. Y is the amount of money, and then x is the number of cakes. And that's important because, again, here it says how many cakes, so I know that I just need to know the x number, and then I'm done. I don't need the y. I don't want to report the y out. All right, so expenses is how much money that you have to pay. That's still an amount of money, so that's okay. I can still use the same y. So y is equal to, and here I've got a $12.25 per cake, so that's going to be a slope because a per usually means a slope. That's a rate. And then $1.25 for the mixer, which you have to pay once. That's like a y-intercept. We have to pay the $1.25 first, so it's like going to $1.25. And we're going to pay $12.25 each time, so we're going to increase by $12.25. So y is equal to 12.25 x plus 125. Now again, we have our options. If we want, we can solve this by hand. So we got y by itself, so that's pretty nice. We can just go ahead and do another substitution if we want to. We could take this 30x and plug it in. So we'll get 30x equals 12.25x plus 125. But we can see kind of the one problem here is we're subtracting 12.25x from both sides. And 30 minus 12.25x is 17.75, which doesn't seem like a really good number to have to divide by to get to the end. I think we're probably going to have to go to the calculator anyway. So it might have been a better one to just go ahead and graph these. But 125 divided by 1775. We get 7.04. Okay, so again, it's a real world problem, so we have to understand what this means. I guess I didn't need the whole big bar. All right, so what this means is that he's got to sell 7.04 cakes. So we have to say, all right, well, he can't sell 7.04 cakes. It's either going to be 7 cakes or 8 cakes. The problem is that 7 cakes is not enough money. 8 cakes is enough money. So we have to answer with 8, because 8 is the one that does give us enough money. At 7, he's just a little bit short. We could plug it in. We can try it out. If it was 7, y equals 30 times 7 is $210. Y equals 12, 20. Ooh, that's not where the parentheses go. 0.25 times 7 plus 125. And again, probably going to use a calculator on this one. Maybe. Let's see if we could do it. 84, and that's another $1.75, so 85.75 plus 125. So that would be, is that right? This is why I want to double check sometimes. 4, another $1.50. Okay. Yep, that makes sense. So we get 8 and 12 is 20, so 200. We got 5 and 5 is 10, so 210.75. So we have just not enough. So he's out 75 cents if he doesn't sell that last cake. Again, since he wants to have his revenue equal his expenses, he's got to get one more cake. Otherwise, his expenses are too big. Now we should double check. So always double check with a graph, because again, these decimals do make us cause for pause. So 30x and 12.25x. Again, we said that we were gonna, if we started, we'd start here at home. Now, based on our answer, I'm just gonna change my y. I know we gotta make like 200 bucks, so let's just go out to $300, and we could see, okay, yeah, there's intersection. And yep, that makes sense. So 7.04 cakes is about $211, and that matches with what we had. So 210 wouldn't be enough, so we need that extra dollar for that extra little piece of a cake. So we'll go ahead and we'll snag this. Because again, if you wanted to solve it with a graph, you're more than welcome to. And we can see we get that same 7.0225 answer. So either way we do it, it still works out. All right. So for number 8, we have what is the solution to the system? Again, if you want to graph it, you can graph it. Since they're stacked on top of each other and the letter is not by itself, this looks like a good one for elimination. Now this one is free because if we add them up, we do get a 0. Those do cancel. So this is a great one for elimination. So we get 9y equals 90. So divide both sides by 9. We get y equals 10. We'll just plug this 10 in. We'll plug it in for y, not for x. So we get 2x plus 6 times 10 equals 100. 2x plus 60 is 100. 2x equals 40. And we get x equals 20. So we'll report our final answer, always x comma y. So final answer here is going to be 20, comma 10. So remember, it's always x, y. This time we did get y first, but we always put the x first, even if we solve for it second. That was pretty quick. Now, if you want to solve it with a graph, not too bad. 2x plus 6y equals 100. And then down here, negative 2x and 3y. Equals negative 10. All right, we'll go back home again. Again, I don't even see the red line. I'm going to use the zoom out because I know I'm pretty close to 10. So if I zoom out twice, I get 20, 10. Again, if we're just solving, you can use whatever method you want. That's kind of the fun part about this section. You get a lot of freedom as to which of the three methods you like the best. So there we go. We found the solution. Solution's at 20, 10. It's where they cross. So remember, always where they cross. So far, which ones have we been able to graph? 8, 7, 6. I guess we should probably graph 6. We should graph 6. I'll do that at the end. 5, 4. We didn't graph it. We could do it with a graph. 3, we graph a graph. 2, we did a graph. 1, we made a graph. That's a lot of Desmos. There's a lot of things you can do with the graphs. Number 9, we can actually do this with the graph as well, because it just asks which one has the same solution as the system shown below. So we just have to find out where else these things cross at the same point. There's a lot faster way to do it than graphing them all, of course, and that is to say, all right, when we did elimination, we multiplied our equations. If you multiply an equation, you get kind of the same solution. So you always just divide it back out. So I want to analyze all of my equations. So if I want to go from 3 to 6, I'd have to multiply this one by 2. Now again, that's not the best thing to do, but it's something you could choose to do. If I were to do that, then this equation would be 6x plus 12y equals negative 4. So if I look to see which ones I've got, this one's out because we had negative 2. That one's out because we have negative 2. So we got 2 other options then. So we're between C and D. So now we have to actually do a little bit of work. So for C, it looks like I got negative 5. So to get that one, I'd have to multiply by negative 1. Oops. All right. So negative 1 times 5x is negative 5x. Negative 1 times 2y is minus 2y. Negative 1 times 3 is negative 3. And that actually checks out. So all of these worked out. So I'm going to pick C. Now, if I wanted to try D, I could. I'd have to think, okay, to get from 5 to 15, I'd need to not multiply by negative 1. I'd need to multiply by 3. I would still need to distribute everything. But then I would get 5 times 3 is 15x. That's good. That's what we want. 3 times 2 is 6y. That's good. That's what we want. But 3 times 3 is 9. That's not good. That's not what we want. So it is a lot like the spot the error stuff that we did in class. We're just picking out which one works. Now, if we want to do with Desmos, it is going to take a little bit extra time. What we're going to do is type in the first set. So 2x plus 6y equals negative 2. All right, then we got to get the bottom one in. 5x plus 2y equals 3. All right, and so we have our coordinate pair as our answer. So that's 9.917. Oh boy. All right, well, we're going to store this over here. So 0.917. If I were you, I'd just write this on your paper. And then negative 0.792. All right, so I'm going to change this color. Let's make that one black. All right, so we want that to be basically where the answer is. So what I need to do is turn these ones off, and I need to try each of the equations, which is why it's going to take a while because we got to try all 4 choices until we get the right one. 6x plus 12y equals negative 2. Move this line out of the way so it's a little easier to see. 6x plus 12y equals negative 2. All right, and then let's change these since we're trying these out. We'll make them different colors. So green. All right, so we can see, all right, that looks pretty solid. It goes through the dot. Might be good. All right, and then over here we got 10x plus 4y equals 6. All right, that's looking pretty close. But if we look and see where they connect, we're going to have to zoom in. We can see it's just so slightly off, 0.833 and then negative 0.5833. So even though the one went almost straight through, the other one missed. So that one's out. So that's how you can tell if that one's not good. All right, those both green. Green and purple. All right, so we can see that's how we can tell it's not correct. So we got a different answer. However, if we were to try the right answer, so negative 4. This is going to be pretty cool. We can see that this is actually an answer. 10, 4, and 6 actually does work out. Even though that wasn't the answer down here, it would have been okay. If this equation were over here, it still would have been the right answer. We just wouldn't have multiplied by negative 1. We wouldn't have multiplied by 3. It looks like if we multiplied by 2, we'd be safe, because 5 times 2 is 10, 2 times 2 is 4, 3 times 2 is 6. But negative 5, negative 2, negative 3. So 5, 2, 3. See, boom, right through that dot, right through the black dot. That's exactly what we want. So that's how you get the answer. So a lot longer with Desmos, but definitely doable. So if you want to do it with Desmos, you're welcome to. This one does take a little bit longer to do that. Cool. So for 10, all right, what's the solution to the system? So again, not too bad. We can see they're stacked up again. So we got one letter is not by itself. Pretty good choice if we just want to use elimination. So we can see here we've got a 2, so we're just going to multiply the whole top by 2. Here we've got a 4, so we're going to pick negative 4 for the bottom, and then we're going to go ahead and multiply. So we have to distribute all these pieces. So 2 times 4 is 8, 2 and negative 2 is negative 4, 2 and 8 would be 16. On the bottom, 4 and 2 is negative 8, 4 and negative 7 is negative 28. Negative 4 and 20 is negative 80. So if we add those up now, we should be in business because the x's are going to cancel. If we tried to add them up here, we'd get 6 and 5. Wouldn't work. You got to get 0. Without 0, it doesn't work. So 4 and 28 is negative 32y. 16 and negative 80 is 64. We can divide both sides by negative 32 to get y equals 2. All right, so we got y. Now we take the y and we plug it in. We can plug it into any equation. I'm just going to pick the top one because I'm taking this one the laziest way possible. So I'm just going to go right to the top and go 4x minus 2 times 2 equals 8. 4x minus 4 equals 8. So I'll add 4 to both sides. 4x equals 12. And I end up with x equals 3. Final choice. Again, remember we would do it as a coordinate pair. 3 was the x, 2 was the y. So we get 3, 2. So that's how we can do it by hand. Again, I did it with a level 2. So if you want to do level 3, it's actually a little bit faster. If you just multiply this bottom one by negative 2 or divide the top one by 2. Negative 2. Then you don't have to do one multiplication, only one distributing. Let's make sure we got the right answer. It's another one you can put into the graph. 4x minus 2y equals 8. We'll turn that color back on. And then on the bottom, 2x, 7y, and 20. All right, we'll go back home. And right there, 3, 2. That's exactly what we want. Guess what? Didn't go. Not yet. We got the answer. So that's it. So again, another one that you can just throw into the graph. If you like solving things with the graph, go for it. Let the computer take care of the calculations, and you can do the higher order thinking. You can do the analysis work and realize that that is the answer. The answer is 3, 2. All right, for 11, we got to figure out, we got 6 slices of pizza and 4 drinks is $17. So 6x plus 4y equals 17. And then the price of 4 slices of pizza and 6 drinks is 18. We have to figure out how much one drink costs. So again, I got to be careful. In this case, x is pizza and y is drink. So if I get the y, I'm done. I just need to get the y. So I don't care about the x. I don't care how much pizza costs right now. I'm just going for y. So just like the last one, we could take this and see, all right, we're going to multiply this one by 4. And again, we can multiply this one by -6. If we tried to add them, we'd get 10 and 10. Doesn't work. You got to get 0 if you want to add them. So let's go for it. We got no letters by itself, so elimination is great if we're doing it by hand. So 24x plus 14y equals 40, and 28 is 68. 6 times -6 times 4 is -24x. Perfect. We want to get rid of those. 6 and 6 would be 36. It's negative, so that's fine. And then -6 times 18, so that's 48, -108. Now again, those numbers look a little bit big because we did a level 2. If you wanted to go advanced, you could probably see that there are some smaller numbers to use. You're still going to have to do 2 numbers unless you want to do a fraction. So multiplying this by -1.5 would have been the fastest way to do it. So if you're interested in the fastest way, that would be the fastest way because that would turn this 4 into a -6. And you could add them really quick. All right, either way though, so these are going to cancel, so that's good. 14 and 36 is -22y. 68, 108 is -40. And that's not looking too great because it looks like we're getting a really weird fraction. So I might need to double check my work on the graph. So I get y equals 40 out of 22 or 20 out of 11. That seems like a really weird price for a drink is 20/11ths. But hey, let's see what we get. Let's see if that makes sense. Is that what we got with our result? So 6 and 4 is 17. Oops. And then we had 4, 6, and 18. All right. Yeah, they got 1.5. All right, so let's go back and let's double check. So this is a good thing that we have with the graph here. All right, so where did we mess up a little bit? So let's double check. We got 24. That's it. 4 times 4 is not 14. All right, so that's good. So we know this is supposed to be 16, which means that this should not be 22. This should be 20. All right. So it's a good thing we double checked. So again, we saw an unreasonable answer. Like good mathematicians, we went back and checked our work. We played spot the error again with our own error. All right, so y is supposed to be 2. All right, like we said, we just needed to get y. So that's it. We're all done. Again, if you just wanted to solve it with the graph, go for it. Again, the one danger is you have to remember which number is the answer. You can't say both because the answer is not both numbers. The answer is only the 2. So you want to pay attention to the context of the question. All right. We're not taking a break right now. All right, so for 12, we want to graph the inequality. So now we're into some of the stuff that was after the quiz. So everything from before was from the quiz, and literally all these questions, we could have graphed them all. But we're actually going to do even more graphing because we have inequalities. So we've got y is greater than -2x plus 1. So again, we want to ask ourselves the first question, are we going to do dash or solid? And in this case, we can see there's no little equal sign. So that means we're going to pick the dash. Then we got to decide shade up or shade down. If we look at our sign, we've got a y is greater than. Greater than is going to shade up. So we're going to pick up. All right, other than that, we got our b. We have our y-intercept, so we'll just jump right to 1. We have our slope. We have m. So we're going to go down 2. And then over 1. Oops, not over. We're going to go right 1. Always want to go right. if you can. So down 2, right 1, down 2, right 1, down 2, right 1. We can go back, up 2, back 1, up 2, back 1. We want a dashed line, so we'll put the dashed line in. Remember, that's what I'm grading. Grading if you got the dashed line or the solid line. And then we're shading up, so I'm also grading this. So those are all the parts that I'm grading. So you can see there's 1, 2, 3, 4 things that you want to do. So there's 4 things that's pretty easy for me to go look at and grade. Do you have this dot in the right spot? Do you have the right slope? Is it the right type of line? And is the shading in the right place? And if you're not sure, we just double check. Y is greater than negative 2x plus 1. All right, let's turn that one off. Is the dot in the right place? Yep, it's at 1. Is the line dashed? Yep. So 0.50 is a little hard to see, but remember we can hold and slide. So we got 1, negative 1. Yep, and we're shaded up over here. Perfect. So that's it. It's all done with number 12. Pretty easy, and again, you can use Desmos to help out. For 13, we have to find out what this one represents, so we're kind of going backwards, and that's fine. So again, the first question is it dashed or solid? Well, if we look here, it's dashed, so that means it's either going to be one of these two. Then we got to decide, is it going to shade up or down? We see we're shading down, we're shading below the line, so that means we need a less than or less than or equal to. And the only one that matches up in both options is the less than. And if we look, that's the only thing that's different between all the choices. So this one was just testing to see if you could see which symbol to use. Again, you can throw them into Desmos and double check them. So let's just do that just to be totally safe. So y is less than 1.5. X plus 3. And again, if we look at that, and we look at that, that looks pretty good. I'm pretty happy. Again, 3, negative 2. Oh, that's supposed to be minus 3. That's fine. All right, so we got 2 and negative 3. All right, 2 and negative 3. Again, the only thing that's different between these is going to be this thing. So that's why I got tricked, is because I'm just looking at the shape. So if I had a plus or greater than, it would be the other side. And again, if we had the or equal to, we would have the solid line, which is wrong. All right. For 14, for the graph of the inequality, the area above a dashed line represents the points 5, 9, and negative 3, 9 are shaded. Which inequalities does this graph represent? So this one is where we got to put our thinking caps on, because this one's a little bit tricky. So we know we got 2 points. So if I were to just go ahead and make a graph, that's probably a bad place to do that, because we got to go all the way up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we need to be at 5, 9. And then negative 3. Ooh, that's at 10. We'll move that dot down. And negative 3, 9. Okay, so I've graphed each of these points. Let me do these in different colors. It's a little bit more obvious which is which. Now we want to connect those with a dashed line. So let me go grab my line. We'll make a nice dashed line. That's not a very nice dashed line. Let's try that again. All right, so we'll make a nice dashed line, and we can see the type of line that we have. So we can see this line is just a horizontal line, so it's just a flat line. All right, so that's pretty good. It also tells us that we have to do the area above. So if we do the area above, that's up here. So it looks like we actually have all of our points. Now we could just do this one traditionally. So we know, again, we've got dashed, which means we're going to pick one of these. We're shading above. So we know it's going to be greater than or equal to or greater than. So our pick for this one is going to be the greater than. And then we have to remember which letter that is. Well, we don't have to for this one, but it's easiest if we do, just to remember that this one's going to end up being y is greater than 9. But if you want, you could actually find the intercepts. So we do have our intercept here. So b is equal to 9. And we have our slope. So we have to find out from here to here, we're not actually moving over at all. So if we really wanted to go in depth, we could do y2 minus y1 over x2 minus x1. So that would be 9 minus 9 over negative 3 minus 5, or 0 over negative 8, which is 0. And that makes sense. We don't have any slope. We're just flat. So m is 0. So if we were to do y and mx plus b, so y, we know this is a greater than. That should be in purple. 0x plus 9. And we do get our answer that we had over here. Y is greater than 9. That's it. All right, so why is that one tricky? Well, there's not really a good way to throw that one into Desmos. If we wanted to, the best we could do is we could put these in. So 5, 9, and negative 3, 9. I'm actually going to turn this off. 5. We'll put these in as a table. So this is a good review if you wanted to do what we did last semester, because we're going to have to put in y1 tilde mx1 plus b. And if we zoom out, we do get that line, but it's a solid line. And there's not really a good way to turn it into a dashed line, just from right here. But at least we get the shape of it. And then we have to kind of, again, logic. Okay, I want to be above that. So if I know I've got this, I've got the m and the b. So I can type in down here then, y equals 0x plus 9. I get the same thing. Now, if I know I want to be above, I'd have to pick greater than. And you can see we get the dashed line. If I were to pick less than, I'd have the wrong one. If I were to type greater than or equal to, I'd get the solid line, and I'd know I'm wrong. You can do it, but it's a little bit harder. It's probably easier just to think about it and remember that the horizontal lines with slope of 0 just are the ones that are the y's. All right, kind of same thing, except we've got just the opposite idea. So in this case, we've got the point 4, 0, 1, 2, 3, 4, 4, 0, and it says we've got a dashed vertical line. So again, we're dashed, so let's go ahead and draw in our dashed line, but it's vertical. So a dashed vertical line would look like that. And it says we're going to shade to the left. So if we shade over here. So now we have to remember that these ones, when they're vertical like that, those are all the x's. So I get x, since it's a dashed, I'm going to go less than. So remember, dashed is either going to be less than or greater than. And then left is going to be less than or equal to. And this is from Unit 1. So that's just stuff that we had from Unit 1. So x is less than, and we're given the point 4, 0, so 4. So there we go. So that's what we got. Again, probably easiest just to throw in the answer and double check the answer to see if it looks right rather than trying to solve it in Desmos. So x is less than 4. If we throw that in, that looks pretty good. I'll turn these points off. So we're going through 4, 0. We are a vertical dashed line, and everything's shaded to the left. So that looks pretty solid. All right. How much we got? A couple more. All right. So next one we got graph system of inequalities. Again, if we want to use Desmos, that's very helpful for us, especially because we're in standard form here. So we'd have to find all of the intercepts. If you do want to do it by hand, that's fine. We got a couple options. I guess we'll just get the intercepts and logic it out. So if x equals 0, and then we'll do if y equals 0. So for this equation, if x is 0, we get 3y is less than or equal to 6. Y is less than or equal to 2. And then if y is 0, these would cancel out. So x is less than or equal to 6, and that's already solved. So I've got my points. I know it's an or equal to, so I've got y is less than or equal to 2. X is less than or equal to 6, which would be over here. And I've got a solid line, so let's go ahead and throw a solid line in. And so this is kind of the tricky part, is y is not by itself. So we can't use our regular trick of saying less than is below. We have to think about it. And to think about it, we'd need to try a test point. So we would test 0, 0, and say 0 is less than 0 is less than or equal to 6. 0 is less than or equal to 6 is true. So that means we do want to shade down here. So we're going to shade this area down here. All right, for the other equation, we do the same thing. If x is 0, we get y is less than, not or equal to. Y is less than -4. And then for if y is 0, this would go away. So we get x is less than -4. So we get -4, -4. We're going to do a dashed line. So again, we'll just extend that a little bit. And since a letter is not by itself, again, we have to pick another test point. So we're going to try 0, 0 again and plug it in here. So 0 plus 0 is less than -4. 0 is less than -4 is false. So we do not want to come over by 0, which means we're going to shade way down here. And hopefully we did that right. Hopefully we got the answer. Again, I would recommend throwing this into the graphing calculator. X minus 3y equals 6. Let's get rid of that. Let's come back up here. All right. And then x plus y less than -4. All right. Does that look right? Did I type that in right? I did. So let's see. Oh, see, it's always good to double check. We made another mistake. We left off this minus sign. This needs to be negative, 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 negative. All right, so this point shouldn't be there. This point needs to come all the way down here. So this line needs to go this way through those 2 points. All right, and then we need to get rid of all of these blue parts. Okay, so we need to redouble check. All right. So 0, 0 we said is still going to be true because we did this math okay up here. So we got to go this way then. So we're going to be above. All right. Does that match with our graph? It does. I'll go home real quick. So we've got our dashed line, our solid line, and we can see the double shaded region is over to the left. So that matches with what we got over here. Our double shaded region is over here to the left. So our answer is going to be all this stuff. So that's going to be where the final answer is. Cool. When you make it, again, the blue and the red, you would not need to write down. You're just doing the purple, just like we had in the practice in Savas. You can just paint in this. So you can just shade in this section if you want. You don't need to do 2 different shades. All right. 17, what system shown in the graph? So the blue one looks like it's going to be easier because it's a vertical line. So we know vertical lines are just going to be X, and then it's to the left and solid, and it's at 1. So remember, because it's left is going to be either less than or equal to. And since it's solid line, it's going to be less than or equal to or greater than or equal to. The one that we pick is the one that's the same in both. All right, so that's our vertical line. So that's all good. That was pretty quick. The red one, it looks like it's going to take a little bit more time because we have to kind of do all 4 parts. So we've got B. B is 1. If we get the slope, we can go up and over. So up 2 to the right 1. So M is up 2 right 1 or just 2. We have to answer our 2 questions. Is it solid or dashed? Well, it's dashed. So it's going to be less than or greater than. Then we have to answer, are we shading up or down? So here we're above the red line, so we're shading up. So that means it's a greater than or equal to. And again, the one that's the same in both is going to be that one. So if we set it up, we'll do y is greater than mx plus b. y is greater than 2x plus 1. And since we want to have the system kind of close to each other, I'm just going to write that right here, just so that the two answers, because we want to have both equations, just so that they're kind of both next to each other. All right, that's what we got for 17. Again, if I want to double check, throw this into the graphing calculator. X is less than 1, less than or equal to 1, and then y is greater than 2x plus 1. And if I look at that, that kind of looks like what I got. I kind of flipped my colors, so we'll just flip the colors so it looks nicer. That one's supposed to be red. That one's supposed to be blue. Perfect. All right, that looks pretty good. They connect over here at 1, 3. They connect over here at 1, 3. Okay, cool. All right, I think we're at the end. I think we finally hit the last question. So for 18, at a concert venue, price of 4 lawn tickets and 5 pavilion tickets is $389. 5 lawn tickets and 4 pavilion tickets is $367. What's the ticket price for 1 lawn ticket, 1 pavilion ticket? All right, we can figure that out. That doesn't seem too crazy. So if we look at this first, 4 lawns and 5 pavilions is $389. So we can rewrite that as 4x plus 3. Whoops, that's not 3. 5y equals 389. Down here, 5 lawn tickets and 4 pavilion tickets is 367. So 5x plus 4y equals 367. And then again, we want to remember which is which. So in this case, the lawn tickets are the x, the pavilions are the y. All right, so we don't have a lot of space. So I'm guessing this one's the intention is to just graph it and get the answer. So I'm going to go ahead and do that. So 4x plus 3y equals 389. And this one was 3x plus 4y equals, was it 387? Probably not, but we'll double check. 367. All right, now again, we don't have anything on screen, and that's okay because we got some big numbers, so we're going to need to zoom out a lot. We know we don't want the answer to be negative, so there we go. Our answer pops in right there. So that's going to be our answer. So that's our result. So we got 65.43. Don't actually need that whole thing. All right, so we got our intersection point, but we need to actually answer the question. So the question is, what's the price of 1 lawn ticket? So it's asking if you know the difference between which one should be which one. So this time they said lawn, so lawn goes with X, so we're going to pick 65. Pavilion goes with Y, so we're going to pick 43. So there we go. So we got it. If we did want to do it by hand, I'm going to go through it kind of quickly here. So we got 4x plus 5y equals 389. 5x plus 4y equals 367. And there's not even any good tricks for this one if we want to solve it by hand. We're kind of just stuck doing our normal elimination. I guess I could pick negative 1.25, but that's not really going to help if I'm multiplying by 389. So I'm just pick 5 and negative 4. Get 20x plus 25y equals, that's going to be a lot. 45, that's 40 and 4, so carry the 4, so we got 19. On the bottom, we got negative 20x minus 16y. 4 times 7 is 28, so 4 times 6 is 24 with a 2. So we're at 24. 4 times 3 is 12 with another 2 is negative 14. This is 19. All right, so we add them up. Those cancel out. That's going to give us 9y. All right, so we have to subtract these. So 15 minus 8 is not 3. Going the other way, 7. 13 minus 6 is 7. 8 minus 4 is 4. Something's a little off because that should come out nice. Is that correct? Yes. Did we do this correct? Oops. 6. So 4 times 8 is 24. 4 times 6 is 24 with the 2. 4 times 3 is 12 with the 4. 5 times 9 is 45. 5 times 8 is 44 with the 4. 16, 19. How did that get messed up? Oh, that didn't. That's a 7. That's not a 3. We're all good. All right, so we can divide both sides by 9. Okay, so that will come out nice. I could tell because I added these up, and I was adding them up to get 14. But now this is a 7, we get 18, which is fair. We get 5 for 45, and then 27 is 3. Oops. We get 53. Uh-oh. We're way off here. All right. Well, how do we get 53 instead of 43? That was the question. I typed that in right. 389, 367. I did not type it in right. Look at that. 4554. All right. That's nice. Okay, so computer won twice. I got to win once. That's because I mistyped it in. Beautiful. Look at that. Not only did Desmos get to check us, we got to check Desmos. All right. There we go. Okay, cool. So we got 31. Okay, so even though my answer didn't match up, it was good. I didn't think that I was wrong. I made sure I double checked. All right, so we got y is 53. And so again, we know this is the pavilion. All right, and then if I want to do the lawn tickets, then I would have to take that number and plug this 53 in. I'm going to plug it into the top again. So we get 4x plus 5 times 53 equals 389. The reason I picked the top this time is because I think it's going to be easier to multiply by 5. 265 minus 265 both sides. So 4x equals, so we're going to get 124. Divide both sides by 4, and look at that. We get x equals 31. So we've double checked them. Good thing we double checked them because we had the wrong answer before. So that's what we got for B, A and B. So then for part C, it says the owner of the venue wants to make at least $100,000 at each performance. Let X be the number of lawn tickets and Y the number of pavilion tickets. Write an inequality to show the number of tickets that needs to be sold. So there's nothing to solve for this time. It just says to write. All right, so if we want to write the inequality, we know we got to make at least $100,000. So we know that we're going to have some price of the tickets. So the price of the lawn times X plus the price of the pavilion times Y is going to be the total. Now, again, we don't want equals because we want to be at least. So we have to change that equal sign just like we said in class. So for at least, we want the total to be smaller because we're allowed to make more money. We just can't make this, we can't make less money. So if we plug in our answers from up here, it was $31 for a lawn ticket, $53 for a pavilion ticket, and we need to make at least $100,000. And that's it. That's actually pretty quick. So there we go. All right. So I did promise I would go back to 6 and show you how 6 looks in Desmos. So if we throw that in real quick, 2x plus 5y is 20. And then slide that back up. And then the other one was negative 2/5 x plus 4. All right, so let's get back home. And so we can see this one is infinite solutions because, again, we can see it's just the exact same. One on top of the other. Oh, it's getting dark. All right, real quick, no solution. If we had negative 4, so this is no solution because these things will never never connect. Those are going to be parallel. That would be a no solution right there. All right, so that's everything. Sorry it's getting dark now, but there we go.